So welcome once again all the students. Today we see the next type of derivative, that is derivative of inverse function. As we know that if y is equal to f of x is 1 1 and onto function, then x equals to f inverse y exists, and that f inverse y is a differentiable, then we can find its derivative, right? So this to the power minus 1 is indicated as a inverse here. Okay, so see the theorem depending on this, that is, suppose y is equal to f of x is differentiable function of x on its interval I, and y is 1 1 and on 2, and dy by dx not equals to 0. This is the must condition here. Also, if f inverse y is differentiable on f of I, then dx of f inverse y equals to 1 upon f dash x, or we say that dx by dy equals to 1 upon dy by dx, where dy by dx not equals to 0. So this is the actually statement of this theorem of inverse derivative of inverse function, that is dx by dy equals to 1 upon dy by dx. But condition is here that dy by dx is not equals to 0 because that is in the denominator of the function, and we know that if denominator is 0, then function is not defined, right? So the proof of this theorem is very easy again, as we prove all the theorems of differentiation by considering the second definition of the derivative given by the scientist Leibniz, that we consider the small partial increments del y, del x, and del u or v, whatever we consider in that, right? So let there be the small increments in x and y, right, that are del x and del y not equals to 0, because they are small increments, they are not 0. So consider this partial fraction dx by dy into dy by dx. We know that dx cancel, dy cancel, we get 1. Okay, so del y by del x equals to 1 upon del y by del x. Del x by del y equals to 1 upon del y by del x, where del y by del x not equals to 0, right? Now we get this equation, then taking limit as del x tends to 0 to both side, what do we get? Limit del x tends to 0, del x by del y equals to limit del x tends to 0, 1 upon del y by del x. Then we know that as del x tends to 0, del y also tends to 0, because we consider that both are the small partial increments. So here we change the partial fraction. See here is del x tends to 0, but we convert it into the del y tends to 0, del x by del y, and equals to here limit changes, limit, that is say limit 1 upon limit del x tends to 0, del y by del x. Okay, then see here, since y equals to f of s is a differentiable function of x, so what do we know? See next, what is this limit del x tends, we know that this is the definition of the derivative given by the scientist Leibniz, that limit del x tends to 0, del y by del x is dy by dx, right? Dy by dx not equals to 0 here. So from these two equations we say that this limit del y tends to 0, del x by del y equals to 1 upon dy by dx, because we know that here limit del x tends to 0, del y by del x, this is dy by dx, right? So as del y by del x not equals to 0, 1 upon del y by del x exists, and it is finite, right? And this is the, again by definition, dy by dx by dy, right? It is exists and also finite. So what we get? We get dx by dy equals to 1 upon dy by dx. This is the proof of the theorem of derivative of inverse trigonometric function, right? Then see the examples depending on this. What is? Find the derivative of the function y is equal to f of x using derivative of inverse function x equals to f inverse of y in the following functions. These are the three functions given. We see one by one. So see here, the first function is y is equal to cube root of x plus 4. So for what we first of all do here, we have to find the value of x in all examples, right? And when we find the value of x, that is, then we have to differentiate that, right? See here, we first find the inverse of the function, that is y is equal to f of x, that is x in terms of y. X in terms of y means we have to find the value of x from this given equation, right? So how we find if we see the x कहाँ दिख रहा है? क्यूब रूट में है. सो क्यूब रूट से बाहर निकालने के लिए आपको इसको क्यूब करना पड़ेगा. सो क्यूब, टेकिंग क्यूब ऑफ दिस टू बोथ साइड, सो y का क्यूब y क्यूब and cube root of x plus 4 is only x plus 4 because cube root of cube is cancelled. Okay, so what we get, see here, x equals to y cube plus 4 है तो इधर आया तो minus 4. Okay, so this is what value of x equals to y cube minus 4, and we know that the theorem is what, dy by dx equals to 1 upon dx by dy. Okay, so what is dx by dy? Dx by dy means derivative of x with respect to y, right? So that means dy of y cube minus 4 because x is y cube minus 4, right? So 1 upon dy of y cube minus 4, and what is derivative of y cube minus 4? By using x to the power n formula, because it is with respect to y. So what is it? Is 3y square, and derivative of 4 is 0, right? So what is 1 upon 3, and what is y? Y is given, that is cube root of x plus 4. So 1 upon 3 cube root of x plus 4 whole square. This is the answer for this function y is equal to cube root of x plus 4. Here condition that x is not equals to minus 4, because if x is minus 4 then this becomes 0 and a denominator is 0, that is function is not defined. Therefore that is the condition here that the x is not equals to minus 4, right? See the next example, what is y is equals to root of 1 plus root x. Again find the value of x from here first of all. Okay, so see x is in the square root, so taking square of this to both sides, y square equals to 1 per root x. So what is root x then? Y square minus 1. So what is x then? Y square minus 1 whole square, because we have to take square of both sides. So again we know the theorem is dy by dx equals to 1 upon dx by dy, that is derivative of x. X is what? Y square minus 1 whole square, so dy of y square minus 1 whole square, right? So what is derivative of y square minus 1 whole square with respect to y? That is 2 y square minus 1 into derivative of y square minus 1, and 1 upon 2 y square minus 1. What is derivative of y square minus 1 with respect to y again? That is twice y minus derivative of 1 is 0, right? So what we get finally by putting the value of y, that is root 1 plus root x is 1 upon this 2 into 2 is 4 root 1 plus root x into root 1 plus root x whole square, because here y square minus 1, right? And this is the final answer actually. But what is next step? Here when multiply this term or this here, square root of square. So square root of square is what? Itself. So 1 plus root x itself minus 1. 1 minus 1 is cancelled. What we get? It is 4 root x into root 1 plus root x is the final answer. That is the derivative of this, right? See the next example, that is y is equal to log x. So again here we have to find the value of x in terms of y, right? So y is equal to log x. Here log, to remove this log we have to taking exponential of both sides. So what is get? While taking exponential of both sides in this step, we get x equals to e to the power y, right? So this is the value of x in terms of y. Again this is the theorem, dy by dx equals to 1 upon dx by dy, that is 1 upon dy of e to the power y, right? We know that the derivative of e to the power with respect to same variable, that is derivative of e to the power x with respect to x is e to the power x. So here derivative of e to the power y with respect to y is e to the power y. Okay, so it is 1 upon e to the power y, and what is y? Y is log x. So 1 upon e to the power log x. E to the power log x means x. So it is 1 upon x is the final answer here. Okay. See the next question. What is, say, find the derivative of inverse function y is equal to twice x cube minus 6x and calculate its value at x equals to minus 2, right? So given y is equal to twice x cube minus 6x, and we have to find derivative of inverse function. Inverse function is what? That is dx by dy, not dy by dx here. Inverse inverse function means dx by dy, that is f inverse x actually. F inverse x means dx by dy, and calculate its value at x equals to minus 2. That means we have to find value of dx by dy at x equals to minus 2, right? So see here, this is the function. We know that according to the theorem, that is dx by dy equals to 1 upon dy by dx. So first of all we have to find dy by dx, that is we know that y is equal to twice x cube minus 6x. So to find dy by dx, we have to differentiate this with respect to x. So see here, derivative of twice x cube is 6x square minus derivative of 6x is 6. So by taking 6 common, we get x square minus 1. And by this using this theorem, dx dy equals to 1 upon dy by dx, we get dx by dy equals to 1 upon 6 into x square minus 1, right? And we have to find, this is the actual inverse, derivative of inverse function, right? The first answer is completed. Find the derivative of inverse function. This is the derivative of inverse function of y. Okay. Now we have to calculate its value at x equals to minus 2. So find dx by dy at x equals to minus 2. So put x equals to minus 2 in this equation. What do we get? See here, 1 upon 6 into minus 2 whole square minus 1. Minus 2 square means 4. 4 minus 1 is 3. 3 into 6 is 18. So 1 upon 18 is the final answer here, right? That is the value of inverse derivative of y is equal to twice x cube minus 6x at x equals to minus 2, right? So this is the answer for this. Now we see the derivative of some standard inverse trigonometric functions. We have to see the inverse derivative of inverse function, but here inverse trigonometric function, right? So see some derivative of some standard inverse trigonometric functions are solved in your textbook. So we consider one of that. Say if y is equal to sine inverse x, and this is the range of x in between minus 1 to 1, this is the range of y between minus pi by 2 to pi by 2, then we have to prove that dy by dx is 1 upon root 1 minus x square, mod of x not less than 1. We have to remember this formula for the problem purposes. Derivative of sine inverse x is 1 upon root 1 minus x square, right? So see how we prove it. Given that y is equal to sine inverse x and this is the range of x and y, so from here x equals to sine y, the sine inverse going towards left side, we get sine. We differentiate with respect to y, we get dx by dy, that is the dy of sine y. We know that the dy of sine y is cos y, right? Now we have to convert this cos in terms of sine by using the identity. We know the trigonometric identity is sin square x plus cos square x equals to 1, right? So therefore this cos written in the square form, so we have to convert it into the square root. So square root of cos square is nothing but cos, right? But it is plus minus is mandatory because we do not know, जब हम square करते हैं तो हमको पता नहीं रहता है. So plus minus root, we know that according to identity cos square is 1 minus sin square and sin is what? X. So we get root 1 minus x square plus minus, right? And since sin y equals to x here, but cos y is positive in the first or fourth quadrant, as value of y is in between minus pi by 2 to pi by 2, that means y lies in the first or fourth quadrant, and value of cos is positive in first or fourth quadrant, that is we know already, right? So therefore dx by dy, this plus minus converted to only positive, that is plus, okay? And by using this theorem, that is dy by dx equals to 1 upon dx by dy, what do we get? We get dy by dx equals to 1 upon root 1 minus x square. This is the proof of the derivative of sine inverse x. This is very important, and all other also important here. That is, after that, this is the cos, same solve cot inverse, sorry, cot inverse x के लिए सॉल्व किया हुआ है. देखो cot inverse x के लिए भी बहुत इजी है. आपने पहला सॉल्व कर लिया हमने sin inverse x के लिए, आप cos inverse का खुद से सॉल्व कर सकते हो, राइट? देन cot inverse x सॉल्व करके दिया हुआ है आपको टेक्स्ट बुक में. cot inverse x भी सेम तरीके से सॉल्व किया हुआ है जैसे अभी हमने sin inverse के लिए सॉल्व किया. बाय यूजिंग दिस थ्योरम of inverse trigonometric function, we got the derivative of cot inverse x is minus 1 upon 1 plus x square, right? Then see, and also we find the derivative of tan inverse x also, that derivative of tan inverse x is equals to 1 upon 1 plus x square, and derivative of sec inverse x is what? It is 1 upon x into square root x square minus 1, or 1 upon minus 1 upon x into square root minus 1. That is depends on the value of x. If x is greater than 1, then dy by dx for value of sec inverse x derivative is 1 upon x into root x square minus 1, and if x less than minus 1, then it is minus 1 upon x into square root x square minus 1. So these are the results of the inverse trigonometric functions, right? So we have to remember this. First of all, derivative of sin inverse x is, see here, derivative of sin inverse x is 1 upon root 1 minus x square. Then find for cos inverse x, that is minus 1 upon root 1 minus x square. Then derivative of cot inverse x minus 1 upon 1 plus x square. So derivative of tan inverse x 1 upon 1 plus x square. Then derivative of sec inverse x 1 upon x into root x square minus 1, and then derivative of cosec inverse x is minus 1 upon x into root x square minus 1. These are the 6 standard functions of trigonometric function, inverse derivative of the standard trigonometric functions. 6 formulas are there. We have to remember for the problem purpose. Okay. Then see here. Yes, some important substitution. While we have to solve the examples, we have to use this substitution. Already this substitution chart is given to your textbook. So remember this. First of all, you have to write it in your notebook and then remember it. Right? कैसे याद रखना है? अगर ये एक्सप्रेशन आपको एग्जाम्पल में दिया है √1 माइनस एक्स स्क्वायर इस टाइप का कुछ भी, तो आपको सब्सटीट्यूशन करना पड़ेगा x इक्वल्स टू साइन ए थीटा और x इक्वल्स टू कॉस थीटा, दोनों में से कुछ भी एक. आफ्टर सब्सटीट्यूशन वी हैव टू प्रोसीड फर्दर फॉर दैट एग्जाम्पल, राइट. और अगेन दिस इज एक्सप्रेशन, दिस आर द सेम वन, राइट. Then if there is x square root x square plus 1, the substitution is this. So in this way we have to remember all these expressions and their standard substitutions, right. So try to remember this chart, and some examples are given to you on the this topic, that is derivative of inverse function, inverse trigonometric function both. So try to solve that, and this is enough for the day. Okay. We see you tomorrow.